Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2, Advanced Foundation Engineering. Would like to present our water tank tower with a capacity of 100 tons water to our fellow lecturer, Prof. IR Technologies Dr. Adnan bin Zainul Abidin. Our team is led by MOHAMED AFIQ bin Muhammad Arif Tan as lead consultant, HAMSE Muhammad ABDILAHI as lead designer, me myself Amir bin Amir as structural engineer, and also Nur Azyan Syafiqah binti Muhammad Yahya as geotechnical engineer.
Rahim. Background of study. Foundations are crucial for building barrier in the soil as they provide structure support. The weight of the building is supported by the earth or a rock beneath the foundation. The foundation is a part of an engineering system that contains load-bearing components to the ground. Shallow foundations have a larger base than deep foundation and are commonly used for lighter structure with a soil support at shallow depth. Shallow foundations are cost-effective and require less drilling or digging. Deep foundations are necessary when building on a subsoil or a sandy company background. Machu Engineering was incorporated on December 2015. The company is located at Pakit, Johor Bahru. Since its formation, the company is providing civil and geotechnical engineering services to the government agents and private sectors. The company provides specialized surveys right from the site investigation, soil and foundation, soil laboratory, concrete testing and curing. Project background. The project focuses on the foundation for water tank tower with a capacity of 100 tons water. The location of the project is at Taman Setia in Johor Bahru. The company carried out research on sustainability of foundation depends on the existing soil at the location. Secondly, site investigation have been conducted in the site. As you see, this figure shows us site location. Objective. This project includes objective list below. First one, to calculate the value of ultimate bearing capacity and settlement. Second, to design the foundation for the structure to obtain necessary information on the subsoil condition.
Methodology. A crucial part of every town or city's life-saving infrastructure are elevated water tanks. Due to the lightweight stage of mass, they are susceptible to earthquakes and utilized to retain water for different uses, including drinking and others. Tanks are used all around the world to store things like water, oil, chemicals, and dangerous substances. For the building foundations, the superstructure serves as a supporting and anchoring construction system. Additionally, the load was in charge of transportation large loads and was carried straight to the floor. Project flowchart. First, we need to identify a bore log at different locations. Then, we need to determine the load to be carried by each column, analyze soil profile, design the foundation, settlement checking, design justification, and lastly, design detailing. Water tank specification. We need to design a water tank using STEAM software and include the load values involved to get the load that the foundation needs to accommodate. The specification of the water tank built is based on the load that needs to be accommodated, which is 100 tons. For our water tank specification, the width of the tank is 6 meter, length is 6 meter, area of water tank is 36 meter, and the total of elevated water tank height is 13 meters. Now we move on to data collection. The value for this project was obtained by referring to Eurocode 2 standard. The structures are subsequently examined using manual calculations and STEAM software, especially for foundation design and settlement verification. In order to produce a suitable proposal for the foundation design in this project, the data from the STEAM and manual calculations are also compared. So these are the pile foundation key plan and also the load on pile from STEAM software.
Okay, hello. My name is Mohamed Adlafi, and I will talk about the methodology of the project. Okay, since the site investigation report boring log provided the end value from the standard penetration penetration test, we can use the Meyerhof equation, which correlates with the SPT result at a QP. QP is the pile pond bearing capacity, and also QS, which is the pile frictional resistance, which correlate with the SPT value, Meyerhof equation too. Okay, and the resultant ultimate bearing capacity value will determine whether the pile parameters such as the pile length, shape of pile size, which is in circumference of area, depending on the shape, and whether it is single pile or group pile, and then we check whether it is suitable for the design load calculated via Extreme software of the structure of the 100-gallon water tank. Next, we also after we have received the suitable pile with the design load, we also need to use the settlement equation to determine if excessive settlement will occur afterward on the pile. Okay, this is the equation. Okay, if the settlement calculated is under 50 millimeter, according to Eurocode 7, then the design pile parameter can be accepted. Okay, that's all from me. Thank you very much.
Okay, for the result and discussion part, in this project, each group is required to obtain a ball-out report and design water tank to determine the load to be carried by every column. The data was used to perform this project were taken from the ball-out of Department of Irrigation and Drainage, Johor Bahru, Johor. The calculation were made for borehole number 1 at column P1C1, P1C9, P2C8, and P3C5 using Meyerhof method. We get the maximum total depth of boring is 22.51 meter, refer to the ball-out 1. The load for all the columns were computed using Esteem software, and the minimum load, we get the minimum load is 425.3 kN and the maximum load is 2083.2 kN. Okay, in this project, we have to determine the design of foundation and to perform checking of the settlement. Okay, the calculation made will determine whether the pile used will be single pile or a group pile. If the design load is bigger than the ultimate bearing capacity, it is not suitable to use single pile. Hence, it's needed to be redesigned as group pile. Okay, the pile size used for all the columns are not the same. Firstly, in case 1, we design using a circular pile with dimension of 0.55 meter times 0.55 meter. Second size is 0.6 meter times 0.6 meter. Next size is 0.4 meter times 0.4 meter and 0.75 meter times 0.75 meter. The length of pile is same, which is 12 meter. The factor of safety used in the calculation is 3. To do the comparison, in this project also designed for case 2 using different pile size and pile length. We design using a square pile with dimension of 0.35 meter times 0.35 meter with length of pile is 10 meter. While with square size 0.375 meter times 0.375 meter with length of pile is 11 meter. And 0.4 meter times 0.4 meter with length of pipe is 9 meter. Based on the manual calculation, in case 1, column C1, C9, C8 are single pile, but column C5 required to redesign from single pile to a group pile as the design load is bigger than ultimate bearing capacity. However, in case 2, column C9 and C8 are required to redesign from single pile to a group pile as the design load is bigger than ultimate bearing capacity. While column 5 cannot bear load, even pile acts as single or group pile. Okay, settlement calculation had been done for all columns in the condition of soil for the columns is more to sand. It was found that the settlement for all suggested pile in case 1 does not exceed the maximum value for the sand soil, but for the case 2, the settlement for all suggested pile does exceed the maximum value for the sand soil. Okay, in conclusion, from the result, it has shown that in case one of the suggested pile size and length are suitable for our column, and only one pile is in specific column need to redesign from single pile to group pile, while in case 2, all the column need to be redesigned to group pile. Okay, group of pile mean when we have more than one pile in a row and used when column load is heavy. Okay, the soil condition for this project is more to sand. So to increase the foundation strength, we suggest building a deep foundation from pile because we assume it has weak soil properties. Okay, for the recommendation, soil improvement will be suggested in the discussion, which is reinforcement of stone column. Okay, the advantage of this improvement is it will increasing the strength to improve stability, reduce deformation due to distortion or compressibility of the soil mass, and reduce natural variability of soil to make it more economical.